Okay, so in this case, we've got sodium sulfate, and we've been given the hydrated mass, and we've also been provided the anhydrous mass, right? So the hydrated mass, as you can see, is 2.77 grams. The anhydrous mass, 1.51 grams. And we effectively need to work out, well, what's the value of X here, right? Now, effectively, what the value of X means is, for every 1 mole of Na₂SO₄, how many moles of H2O are we going to have? Long story short, but it's going to be an integer value anyway. But how can we work that out? Well, we're going to need some molar values, right? So we can first work out what the moles of the sodium sulfate is. So although we have initially been given the hydrated sample mass, we've also got the anhydrous mass, which is what we it's going to be useful for working out the number of moles of sodium sulfate. So we're going to be using the equation that the number of moles N is equal to the mass divided by the molar mass, right? And in this case, the mass is going to be for sodium sulfate, right? So the number of moles of Na₂SO₄ is going to be equal to, and then 1.51 divided by, and then what we need is the molar mass of Na₂SO₄. So we can work that out from the periodic table. So Na2, so that's going to be effectively 23 times 2 plus S, right? So 32.1, right? And then plus the O4 component, which is going to be effectively 4 times 16, okay? And this is for the, it's hard to write it here, but MR of Na₂SO₄, right? So it's going to be equal to this. And if you do work that out, you should find that that comes to 142.1, and that's going to be in grams per mole. Okay, so with that value in mind, so you can put that here, so 142.1, and that's going to give us a value of the number of moles of Na₂SO₄, right? And in this case, it's going to be 0.010626, right? And that's going to be in moles, right? So that's just to 5 significant figures what that would be. So we've done that side of things, but we also need to, of course, compare it to the number of moles of the H2O. But we haven't been explicitly given what the number of what the mass is for H2O, right? If we wanted to use this equation, we also need a mass of H2O. But we can use just some arithmetic here. So if we take the hydrated mass and subtract from it the anhydrous mass, what would be remaining is effectively what's contributed by the H2O, right? So if we do that, so 2.77 grams minus 1.51 grams, right? That's going to give you what the value is of the H2O mass, right? Which in this case is effectively 1.26 grams, okay? And okay, so if we're going to say the number of moles of H2O, that's going to be equal to 1.26 divided by the molar mass of H2O. And of course, for the molar mass of H2O, we simply need to do H2 plus, for the oxygen. So it's effectively 1 times 2 plus 16, right? Which of course is going to be 18, right? So MR of H2O is going to be, and that's going to be in grams per mole, right? So if we take that 18 now, that's effectively going to give us 0.07 moles, okay? Now at this stage, what we're going to want to do is put together a molar ratio. We're going to say for every X moles of Na₂SO₄, we're going to get a certain number of moles of H2O. And so in this case, and I'm going to put the Na₂SO₄ component on the left hand side. So what we can say is for every n, for n being moles, right? So for the moles of Na₂SO₄, let me just write this properly. Na₂SO₄, and then as a ratio compared to the number of moles of H2O, right? And that's effectively going to give us, so obviously for this we've got the value here, right? So it's going to be 0.010626, and that's going to be in comparison to 0.07, right? And as I said, this is actually a question of, well, for every 1 mole of Na₂SO₄, how many moles of H2O are we going to have? And of course, this is not, it's not a 1, right? So what we want to do is we want to get that to the 1. So we want to get that left-hand side to be 1. So the most straightforward way of doing that is dividing it by itself, right? So divide that by 0.010626. Now, because we've done that to the left-hand side, because it's a ratio, we need to do that to the right-hand side as well. So divide that also by 0.010626. And so, of course, on this side, we're going to get 1. And with a calculator, you can work out what the other side is going to be, right? So in this case, it's going to give us 6.5876, right? At least to 5 significant figures. And okay, so in this context, what we want to do is get integer values, right? So in this case, if we round the 6.5876 to the nearest integer value, we effectively need to round it up, okay? So, and that would give us 7. So what we're going to say is that 1 is in a ratio of what it amounts to approximately 7, because we're rounding it up, okay? So it's approximately 7, and therefore x is equal to 7, right? And if x is equal to 7, then effectively we're going to have Na₂SO₄, 7 H2O, okay? And so as you can see, we've got there that x, as it says, will give your answer, x is going to be 7, okay?